Is it possible to make it dimensionless? Then you don't need to worry about the material. So this delta is something omega naught square or omega square. So it is inverse second square the dimension. So this little gamma is damping, is some constant multiplied and small number multiplied with omega naught. So also the whole term is per second square. So the beta here is something like this. The beta and the x4 will make it energy, dimension of energy. Okay. So beta has the dimension of energy divided by dimension of length to the power of 4. You get what I say? Now, my suggestion is try to make everything dimensionless. You hear me?
Yes, doctor.
Yeah. You try to make it dimensionless. And you find the dimension of P. No, I think I just give the suggestion. I think this article did not make it dimensionless. He doesn't make it dimensionless. Okay, let me see. So beta, no, sorry. I've forgotten to open the bracket. The P, okay, the P multiply with this delta here. Okay, and the P, there's a P outside. Polarization got dimension, multiply with this term also. So every term, all these 1, 2, 3 terms, so if you multiply with the P outside, you will have the same dimension as these whole terms. So electric field, you have no problem to find the dimension. Okay, and then the electron charge square, you have no problem to find the dimension. And this you have no problem to find the dimension also. So after you find the dimension, you may want to define some constant so that you can scale every term so that it becomes dimensionless. So P is for polarization. So you look at the P. Okay, P is the amplitude of molecular polarization. So you can look into the electricity and magnetism books, the dimension of P. And hopefully if you can scale this to dimensionless, then you can work with dimensionless. Then you don't need to worry about the material. And actually this, if you refer to the simple material, I don't know whether this, they consider the gamma. Yes, they consider the damping. The damping must be here. Otherwise, otherwise I always like to ignore the damping. Okay. It got a damping, so the damping must be there. Let me think about whether you.
Sorry to
Yes.
doctor.
Yes.
Is
Any
it
question?
possible to end the meeting by 4:30 since we have
Can you repeat?
Discussion
Can,
after this.
you have class after this, huh?
Yeah, 4:30.
For the tea, yeah? Okay, so I think I try to finish in a few, I think I try to finish in a few minutes time. Okay,
Okay.
so here there are ambiguity here, and as I said, there are terms that you can find relating to material. But if you want to depend on material, it's a bit hard. There are too many choices of materials, it will make you confused. So I suggest that you try to scale it so that it becomes dimensionless. So how to scale it? It depends. Because you have, maybe you look at the terms on the left-hand side first. You try to find terms, physical quantities, which has the same dimension as the P here, and related to materials, and try to scale it. But it's not easy because according to this paper do not give any scaling. You keep on using the same, also, almost the same as the equation here. I do not see any scaling. But if do not do scaling, how can he plot the boundary condition? Okay. So I think for this part, I think for the formulas, we have no problems. So at the moment, I will suggest you to do the scaling. If you do not do scaling, then you put the value. I think maybe you try first. For the non-scaling one, you try to find the material. As I go through the website just now, you find optical dielectric, for example, optical glass. Glass will have many resonance frequencies. It can have mechanical resonance frequencies. For example, you play piano and then you have the sound fork, then you can break the glass when it is in the same resonance frequency with the glass. As I said, materials will have many resonance frequencies in different regime. So for optical, you will have the resonance frequencies. So you can find it out, and then after this, you can plug in to all the relevant parameters so that you can find this and also find this. But of course, there are so many terms are jumping around. It's not easy. You have to be very patient. The other possibility is you try to make the terms dimensionless. So this one, of course, has dimension. Has some dimension. This also has dimension. So see whether if you're possible, then you try to make it dimensionless. If you plot dimensionless, then it will be easier. So if you manage to make all this dimensionless, you can make this dimensionless by scaling with certain material parameters. I think maybe I will see you again next week and see whether I think you try to find the values and plot it first.
Okay, doctor. Thank you for your explanation.
And then if possible, next week you show your program, you show your programming.
Okay, doctor.
Right now, you make up your mind which software you want to use.
Yeah. All right, doctor.
C++, Python.
For now, I'm thinking of C++ because the Wolfram is much easier than the Python lab.
You mean C++ is easier than Python? So you decide to use C++.
Yes, doctor.
Okay, so next